Hi there, and welcome to this video where I want to show you a little bit about the normal force and hopefully help you get a little bit of better understanding of the normal force and especially its effect on frictional force. Okay, so let's just quickly go and define the normal force. So the normal force is the perpendicular force exerted by the surface that an object is affected by. There's a by missing. Okay, so basically what that means is if we have an object, and so let's just draw a surface, and an object is on that surface. Okay, my object on the surface. Now this object has a certain mass, but why is this object not falling? Any object with a mass must be attracted by the Earth's gravitational force. So why is it not falling? Well, first of all, the attractive force by the Earth is what we call weight, and that's mass times gravity. That gives me the weight, so it should be accelerating down at -9 or 9.8 meters per second squared. But why might this one not be? That's because he's standing on a surface. Okay, so the surface is countering the effect of gravity, and so it's standing still, for example. Now, if that is the case, that it's standing still, it means that all the forces are in equilibrium, or the net force is 0. That means that the upward force, since there's a downward weight, there must be a perfectly upward force that is equal to the weight, but just in an opposite direction. Negative. Okay, so this is in this case, this is the normal force. The normal force is equal to weight in the opposite direction. Now, this is not always the case, okay? It's just the case in this situation, because the surface is horizontal, its perpendicular force is therefore perfectly vertical, okay, and as a result, that perfectly vertical force is countering all of the weight downwards. But let's look at another example. Let's say we have a surface here, and this time we have an object that is on a slanted surface, okay, with a certain size here. That's my angle. Okay, what is happening this time? Well, of course, again, we have a downward weight, and that downward weight is mass times gravity, and the normal force this time is perpendicular to the surface, so the normal force is in that direction. And what is very likely is that this object is probably sliding down in that direction. Let's say this was a frictionless surface, then it's obviously sliding down in this direction. So the net force is in that direction, because the net force is always in the direction of acceleration. Okay, so what is the size of the normal force now? Is it still negative mass times gravity? Okay, well, it can't be, because if it was negative mass times gravity, then these forces will again cancel out. Okay, now this time what we need to recognize is that the normal force is only countering a portion of the weight. The portion that is in this direction, this size of this size. Okay, so that's the size that he's countering. Now this size is not negative mass times gravity. Okay, so how would we go and work it out? Well, what we're going to do is we're going to look at the weight that is downwards. Okay, so the weight directly downwards, we've got all of the weight. Okay, but some of the weight is perpendicular to the surface, and some of the weight is parallel to the surface. So we've got weight that's perpendicular to the surface, and we have weight that is parallel to the surface. There's the parallel and there's the perpendicular. Now when I put the parallel and perpendicular like this with end to end, then this direction here, that's the weight, that's mass times gravity, and this angle right there is also the angle of theta. Now in a previous video I've shown why that's the case. This is not the purpose of that video, okay, or of this video, but this angle is equal to that angle there, okay, that's equal to theta. Now what I want to know is what is this weight that's perpendicular to the surface. It's actually in that direction because it's weighing down on the surface. Sorry about that. The weight that's weighing down on the surface, because that's the portion that the surface is countering. The weight that's perpendicular, because the normal force is perpendicular upwards, weight would be perpendicular downwards. The normal force can only affect the weight that is on the surface. Okay, so how would we work out that? Well, if you look at this triangle, you'll notice that what we're trying to find is the adjacent side of a right angled triangle. In other words, we're given the hypotenuse and we want to work out that. So in this case, what we have is that the weight perpendicular to the surface is equal to the weight downwards, the normal weight, which is just mass times gravity, times cos of theta, because we're trying to work out the adjacent side length given the hypotenuse. Again, in another video I explained why that is the case. So in this case, this time the normal force is equal to the opposite of the weight parallel to the surface. Sorry, perpendicular to the surface. So in this case, the normal force is mass times gravity times cos of theta. So a lot of the times people use this just as the general formula for normal force, because we could have used it here, because the angle of theta is 0 in this case, and so cos of 0 is 1. So if you say that the normal force is mass times gravity times cos of theta, then when theta is 0, in other words when the surface is horizontal, then you're correct, then you are working out, this is just the magnitude, just keep that in mind, it's the magnitude of the normal force, not the direction. If I want to include the direction, I'll put a negative there. But the problem with that formula is that that's just not always the case. It's not always the case that the normal force is carrying all the weight perpendicular to the surface, even if my surface was horizontal. Let me show you an example. Okay, and before I get to that example, let me quickly just show you where this is now going to become very important. What we've learned is that the frictional force, the kinetic frictional force, okay, is equal to the coefficient of kinetic friction multiplied by the normal force. Okay, so what it means is that when an object is in motion, this object is moving, its relationship to the surface is important, and the amount of weight that the surface is carrying affects the frictional force that it will experience. So for example, imagine a rough surface. The heavier an object is, the more difficult it would be to move that object because of its mass on that rough surface. Okay, and that is because the mass is having an effect on the weight, and the weight is having an effect on the normal force, and the normal force is affecting the frictional force. As you can see here, the normal force is affecting the frictional force. Then, so the more the mass, the more the weight, the more the kinetic frictional force. Okay, so imagine you trying to move we have a massive couch in our house. Okay, so it is it is almost impossible for me to move this couch by myself. This thing is so big. Okay, so we've got this massive couch in our house. If I try to move this couch by simply pushing on it, okay, I almost have no effect on moving it, because, again, why? Not because of its weight, but because of the frictional force. Its weight is causing an increase in the frictional force experienced on the surface. If I was putting it on ice, it wouldn't have any difficulty moving it. It will just take slower to get it into motion, but it will definitely move very easily. So what I have to do when I want to move this couch, I have to lift up this couch a little bit in order to be able to either push or pull it. Now, what am I doing when I'm lifting up the couch? Well, what was happening when I was just pushing the couch is I just had an object that was trying to be pushed in one direction. I had the normal force was equal to the weight but in the opposite direction. And so the frictional force, which was working against me, was equal to negative the weight of the normal force times the frictional coefficient. Okay. But the moment that I pick up the couch, what I'm doing is I'm reducing the amount of weight that the surface has to carry. Okay. The surface is not exerting the full weight anymore because I'm helping the surface. I'm lifting it up a little bit myself as well. So whatever force I'm exerting upwards, okay, so let's say I'm pulling it in this direction, okay, I'm pulling it, so I'm lifting it up a little bit and I'm pulling it backwards. So some of the force that I'm applying, so that's my applied force, some of the force that I'm applying is in the perpendicular direction as the force applied but perpendicular to the surface, and then that's this part, and then I've got some force applied parallel to the surface. Okay, now the force applied perpendicular to the surface plus the normal force is now equal to the weight. So that my normal force in this case, in other words, the force that the earth has to, or the floor has to support, is only the weight minus the force that I applied perpendicular to the surface. So, and this is what is very important. So when we work out frictional force, it is definitely always true that it is the frictional coefficient multiplied by the normal force. But what is very important is that I can't just go and always have a fixed formula for normal force, because normal force is not always fixed. Sometimes it's carrying the full weight, like in this case. Sometimes it's just carrying the weight that is perpendicular to the surface, like a box sliding down a slope. Other times it is carrying only the weight that's left. In other words, someone is pulling something at an angle, that angle there. Now I first need to go and subtract from the weight the force that whatever applied force was applied. So for example, I've seen a question where we had a trailer, and this trailer was being pulled by a truck. At an angle. Okay, and the question was, what was the frictional force experienced by the truck? And they just gave you the frictional coefficient and the mass and a few other variables. But again, in this case, what will we do is we need to go and work out the weight, because for this we need the normal force. Let me change some color to get some. We need to use this formula. That's definitely the formula for the frictional coefficient. And then, but the normal force in this case is not normal. Okay, in this case it is the weight minus the force applied perpendicularly upwards. Again, because it's pulling in that direction, some of the force is lifting it up and some of the force is taking it forward. So the surface is not supporting the full weight, but the normal force plus this force will equal weight. So the normal force is weight minus that force, is weight minus the force applied perpendicular to the surface. Okay, so that's all I wanted to say up to this point. I don't want to look at a lot of examples per se, specific examples, but rather just give you a very good understanding of what is the normal force, and hopefully that is going to be helpful in order to understand the bigger picture of frictional forces.